Okay, shush, shush. Okay, so I'm just gonna kind of go over this real fast. Please stop me if you guys have any questions. Okay. So if you have like a bag of M&Ms, there's red M&Ms in there, and there's green M&Ms and yellow M&Ms, whatever. That's a mixture, but it's not a solution. The reason why is because they're not dissolved in one another. Like if you have a bag full of sand and paper clips, that's a mixture, but it's not a solution. If you have a bottle with oil in it and water, that's a mixture, but it's not a solution. But if you have a bottle with ethanol and water, they're going to dissolve in one another. That's a solution. They have to be dissolved in one another to be a solution. Chromatography, the purpose of it is to separate components of a solution, because you don't need chromatography to separate M&Ms from paper clips. You can just use tweezers, but you need something more sophisticated to separate the components of a solution. So that's what chromatography does. So chromatography separates chemicals in a solution. In thin layer chromatography, the stationary phase is the strip of paper or the thin paste of ground up glass that you paint onto a piece of plastic. The mobile phase is the puddle of liquid that's at the bottom of the container that creeps up the stationary phase. Thin layer chromatography is used for diagnostics. You don't get enough stuff separated in order to use it for manufacturing. You'd have to use column chromatography for manufacturing. For RF value in a TLC experiment, you divide how far each chemical moved by how far the mobile phase moved. And the reason you do that is so that you can identify things in a mixture. Like for example, when we purify this caffeine that you guys made, we're going to do TLC on the caffeine, and then we're going to measure the RF value, and we're going to look on the internet and see what the RF value should be, and we're going to compare it, and we're going to be like, okay, it's caffeine, because it's just going to look like a white crystal, who knows what it is. You use thin layer chromatography in order to tell what it is, and you need the RF value in order to do that. Electrically charged particles dissolve better in water. Like salt dissolves in water, it doesn't dissolve in oil. The concentration of a solution is equal to the amount of chemical in the solution divided by the amount of solution. So if you wanted to do so what's the difference between concentration and volume? Concentration is like how strong or how dense the solution is. Like a super strong glass of Coca-Cola would be super sweet, That's like its concentration. The volume is how much, like if you have a cup or if you have a bucket or whatever. That's the volume. Each of the four variables, this is concentration before you mess with it, volume before you mess with it, concentration after you mess with it, volume after you mess with it. 500 mils of salt water, if it contains 3 grams of salt, you do 3 grams divided by 500 milliliters, and that would be 0.006 grams per milliliter. And then I actually messed up on this one. You guys. This number right here is supposed to be 500 milliliters. And this number right here is supposed to be 600 milliliters. So I think the answer comes out to be 0.005. Is that right?
Yeah.
Okay. So once again, this is supposed to be 500 and this is supposed to be 600. And you could have just changed this to a 600 too and come up with the same answer. A mixture of chemical A and B is run through a chromatography column. Chemical A comes out of the column first. That tells you that chemical B is more attracted to the stationary phase in the column, and chemical A is more attracted to the mobile phase because A came out with the mobile phase first. As temperature increases, particles vibrate more. Any questions so far? When a substance is melting, its temperature does not change. The purpose of distillation is to separate the chemicals in a mixture. The first chemical to leave is the one with the lowest boiling point, or the weakest interparticle attractions is another way you could think of it. Sketch distillation rig. Here's one right here. Heat goes in, heat goes out. So right here is where a liquid turns into a gas. And in this heat exchanger is where the gas condenses into a liquid. Regarding the difference between chemical bonds and intermolecular attractions, chemical bonds hold the atoms in a molecule together, and intermolecular attractions hold molecules together. Of these two attractions, chemical bonds are way stronger. If you make or break chemical bonds, you cause a chemical reaction. And if you make or break intermolecular attractions, you cause a phase change. An example of a phase change is melting. Molecules that are polar have one end that's sort of positive and another end that's sort of negative, or you could have done negative and positive. Polar molecules dissolve in water because of interparticle attractions called hydrogen bonds, and nonpolar molecules dissolve in oil because of interparticle attractions called London forces. The stronger the intermolecular forces are, the higher the boiling point is going to be. The stronger the intermolecular forces are, the higher the melting point is going to be. The stronger the intermolecular forces are, look at that, I messed up at first, the lower the rate of evaporation is going to be, because they're going to be stickier. It's going to be harder for them to evaporate. And therefore, the stronger the intermolecular forces are, the lower the vapor pressure is going to be. So not as much pressure is going to build up in that closed container, because not as much evaporation is going to be happening. If you want to dilute or dissolve a chemical, you're going to need to know whether the chemical is polar or not. So you know whether to dissolve it with an oily thing or a watery thing. Which kind of intermolecular force holds the water molecules in the ocean together? That'd be hydrogen bonds. Which kind of intermolecular force holds propane molecules together in a bottle of compressed liquid propane? That'd be London forces. It's because water's polar and propane is nonpolar. When some of a liquid evaporates, the molecules that leave as a gas take energy with them, and that causes the temperature of the liquid left behind to decrease. Methane and water are about the same molar mass. Why is methane a gas at room temperature, but water's a liquid? It's because water's polar, and hydrogen bonds are stronger than London forces for small molecules like methane and water. Those are small molecules. The answer to the above is because of what we just said, but trip out on this. Like methane, octane's also nonpolar and only has London forces, but the boiling point of octane's higher than the boiling point of water. What's up with that? It's because London forces are stronger than hydrogen bonds for huge molecules, and octane's a huge molecule relative to water. Describe the structural differences between alcohols and alkanes. They're both made of carbon and hydrogen, but alcohols have a hydroxyl group, an OH group. So therefore they're polar. So for this, you're going to need to be able to do all the alkanes and all of the alcohols. You're going to need to know all the names, all the formulas, all the structural formulas, and all the stick structures. So you guys are going to want to quiz each other a bunch. You should just be able to do it like that. So I gave you 3 examples, but that's not going to cut it. You're going to need to be able to know them all. Just boom, like just by heart, you know? Meth, eth, prop, bute, pent, hex, hept, oct, non, dec. So this would be octane or octanol. And this would be pentane or pentanol. And this would be butane or butanol. This is the stick structure for butanol. There's 1, 2, 3, 4 carbon atoms, and then an oxygen to a hydrogen. This is the structural formula for hexane. There's 1, 2, 3, 4, 5, 6 carbons, and each carbon is bound to 1, 2, 3, 4 other atoms. If I give you a formula like this and ask for its name, you're going to say that this is ethanol because you're going to go meth-eth. So you know it's eth, and it's not ethane because it's got a hydroxyl group, an OH group. So it's ethanol. Yeah?
Yeah.